Hello, this is the third and final Greyboxing tutorial, and in this one we're going to talk about vehicular Greyboxing, or Greyboxing for vehicular modular systems, and also asset list creation, and finally getting all of that information and turning it into an infographic design for making sure people understand what this Greyboxing is intended for, or indeed what this modular system is intended for. So let's get started. What I have in front of me right now is a vehicular modular system, particularly a space station set. It's a plug-and-play snap-on space station set inspired by the very real and the very magnificent International Space Station. So now that I have created all of these pieces, perhaps I need to name them. Well, I already have named them and I already have the asset list to go with it. So let's explore what that asset list contains. Now, this file will be shared with you and you will have two examples in it. One is for the old Mosque sets that you have seen in the previous tutorials, and this one is the vehicular version. If you look at the tabs, or the, let's say, columns of information, they are both the same across both lists, but the way I fill them out is different because I have to, use whatever is necessary according to the needs of the modular system. So let's go over the vehicular one first and explore what's inside. First things first, you have to name your set. Then you have to prioritize the function, the primary function of any asset piece. What is the main purpose of this object, right? It can be a unit of sort, it can be a piece of an architectural composition of sort, whatever that might be, you specify the function. Then, if you want to, you can define the sizing, because depending on the type of an object, it can have, let's say, longer or shorter versions, taller or, again, shorter versions, and wider and narrower versions, double versions, single versions, half-size versions. It all depends on the system you're designing, but in some cases you might not even need this, such as in the example of the architectural set that I have created. That doesn't mean that all architectural sets will not use sizing or anything, but in this particular example I'm not using it. And the same will apply to everything. And then we have grouping. And in grouping section, for example, let's look at the architectural one. In grouping section, you can specify the subsidiary, or not subsidiary, but subcategories, subfunctions of pieces in the same group, let's say, or in the same primary function, under the same primary function. Let me exemplify. For example, in the mineshaft example, we have walls over here. Well, all of these three objects can be categorized as walls, but one is a vanilla piece, right in the middle, just a straight piece. One is an inside corner, and one is an outside corner. But being corners doesn't change the fact that they are walls. So I have to further categorize them into different pieces, and we call that grouping. And in that case, we can also explore what sizing might mean. Now, this wall is 2 meters wide, but if I also had a version which was, let's say, 3 meters wide, I might have needed to use the sizing tab for further specifying that this version, this object has many versions depending on their sizes. Okay, but that is not the only type of variation we can incorporate into our asset designs. For example, you can have further variations depending on the material of the object, depending on the texture of the object, or indeed the state of the object. You will specify what those conditions might be, because this is getting, well, as I've said, specific by the minute. So your variation could incorporate material changes or material differentiation, but another person's changes, another person's understanding of variation might be on the level of damage on the object. Maybe the wall is broken, maybe it has a hole inside of it. Maybe if it's a window, it can be open or closed. It can be shuttered or not shuttered. It can be bare. If it's a door, it can be a double-sided door or a single door that you didn't specify under grouping, or you didn't feel the need to, but in the variation tab you might specify that. So it entirely depends on you. As with always, the level of variation, the stage of variation. So you can have one variation A, and it can have two variations under it, 1 and 2. And you can even add more to this. You can have a variation 3 if the Greyboxing or indeed the modular system is incredibly complicated, like over 100 pieces. And that is quite possible. You can have 100 pieces, 200 pieces, 300 pieces in a modular system in extreme professional scenarios. And in those cases, well, you will have lots of variations on multiple pieces, probably. And then we combine all of this information into a single production code, which will give all of these pieces unique names, but using already existing language that you have created. So if you spend a couple of minutes, maybe a couple of hours on this, and then understand how the system is intended to work as a level designer, as a game designer, you can simply read this information and realize, okay, that's what they're talking about. Without seeing the piece, you will immediately understand what that will do and how it will fit when designing with this modular system. But until we can understand that, we will need explanations. These explanations is particularly necessary for people who have never seen your work. So that's why we specify it. Like, this is the floor, it's a vanilla piece, it is the barest piece, the simplest piece we have. It is the vanilla flavored ice cream, and there's two variations on it, A and B. Okay, but what does A and B mean? We don't know what A is, we don't know what B is. Well, you have to explain it, and in this case, A variation is for exterior uses. Let's say exterior, because there's no exteriors or interiors in game design. Everything is in a digital world. But it's for visual sake. It's used in the exterior looking parts of the level, and it's made out of stonework. It's going to have a stony material on it. And the interior floor, apparently, the interior use one, is using the worn out carpet textures. Okay, that's the A and B variations. That doesn't mean that all A and B variations will be separated, will be differentiated in the same manner, but in this case, that's what they do. Okay, and the same thing can be observed on all of these things, all of these separate assets. For example, this is a dome with a pendentive grouping. It has a pendentive, let's say, design, okay, and there are A and B versions. So this is an interior dome. It is sized for specifically pendentive vaults, so you can only place this dome on a vault object, on a vault function with a pendentive grouping, okay, sized for pendentive walls. Its material is apparently plaster over brickwork, okay, and this one is fully enclosed, meaning the dome is complete. But the B version, for example, has an oculus. It has an opening, okay, like so. This is the pendentive vault version A. It's meant to be used with vault pendentive, and this version is B. It has an oculus, an opening on the top for, getting light through to the inside, and it is also intended to be used with the vault pendentive object. Okay, so this is how asset lists are supposed to work. Let's look at the sizing for a minute in the vehicular example. Now, in this context, I'm not using variation 2, similar to how I wasn't using sizing in the first example. But here, sizing really matters to me because I have to not only specify the length of these units for some reason, because they were designed that way, but I will also have to specify if they are single units or, conjoined units, double units. And let me show you that. So this is the space station example. As you can see, I have hab units here. This is a hab unit, single size. It is 6 meters long, okay? This is also 6 meters long, but it's a double unit. As you can see, they are conjoined, okay? So that's how you specify sizing when necessary, and you can have many different sizes of the same object. So take a look at this gangway, this tunnel piece that you can use to connect all of these hab and lab units together. It has a 1 meter long piece, 2 meter long piece, 3, 4, 6. So, and you can add more if you wanted to, but in this case sizing is particularly important because there is absolutely no need to separate these objects through variation like A, B, C, D, because the only thing changing here is the size, is the overall length or overall dimensions of the object, not particularly what it does or how it does it, or the type of textural or material changes on it. You can further specify those details down the line, but the sizing is the most important factor here, so it comes before everything else. Okay? But in the architectural example, for example, the Ottoman old mosque example, I didn't feel the need to specify sizing because I will never have a variation. In my case, I will never have a variation on the size of these columns, for example. They will not be a larger column. They will not be, for example, a wider wall, right? There will not be an arch that spans a greater distance or a shorter distance. If they were, yes, I would use sizing. But in this case, no, I'm not using it. So it all depends on what you're trying to achieve. So design your asset list, or let's say modify this asset list and add tabs or delete tabs accordingly. But always explain and always try to come up with clever ways of separating this information into understandable, digestible information. Okay, so then we have the status. This status is only meant for you or your team further down the line when you're working with other people and you have to track the progress of the completion of these items, of these assets. You would generally update this column when necessary to track the progress of the project, of the production of the project. So it will not be necessary for the presentation, but this is just here to make sure you understand the concept. Okay, so there you go. This is the Google Sheets file, and the way you edit this file and then print it and put it in the presentation is is in a different tutorial. You can check that out, but this is how you generate the asset list. Okay, so well, we have another business to attend to, and that is, well, rendering our gray boxes and creating informative graphical design elements from them. So in this case, we highly suggest using not Maya's viewport, but Substance 3D Stager instead, because it gives you better rendering capability. Also, you can use the, as you will see in a couple of minutes, you can use the PST export option or the PST saved file option of Substance 3D Stager to further separate your objects graphically and do some nifty stuff from a graphical design perspective. Let's talk about that. So this frame size is 4735 by 2636, 4735 pixels by 2636 pixels, and we're going to use that graphical fidelity, that resolution, to our advantage as much as possible. So I have Stager open in front of me, and as you can see, we have the architectural example open, the old mosque example, and we can reset this and then talk about how we get from here to here or there to here. Okay, so let's delete everything, or let's just simply create a new file without saving. Okay, now I have to import all of the pieces into Substance Stager. Okay, so let's start with, for example, the space station. What I have in front of me is all of the space station pieces laid out beautifully. They have their histories deleted. They are perfectly working objects. They have their surface normals treated, or let's say edge softness treated in appropriate ways. Whatever needs to be smooth is smooth, whatever needs to be hard is hard. They also have their transformation frozen as well, so every single one of these objects, as far as they are concerned, are standing in their 0 points. Okay, so now we can select all of these objects and export them. And let's export the selected objects to here. So this is space station all. Okay, it's that simple. Now we can import this into Stager. And you don't need to include the unused materials, and it all depends on what materials you chose to use in Maya in the first place. If you wanted to separate the materials in Maya, you should use Hypershade here to specify different kinds of materials for your objects, but I am using the same shader on all objects because I want to do this separation in Photoshop instead of, let's say, Stager or Maya. Okay? And we don't need to generate UVs for models without UVs. First of all, you really don't need UVs if you're only going to use colors instead of textures. And two, if you wanted to generate UVs, you can do that in Maya by using UV automatic. Okay? Since these objects are never intended to be used in game, they will not be textured. They are just placeholder items. A bit more than placeholder items. They accurately depict the correct size and the correct connection methods for the final stage of objects that will take place, that can be used inside the game. They don't need UVs. They will be changed later on. So you can simply say, do the automatic UV unwrapping, you do whatever, and Maya will take care of the rest. If you checked out the, for example, unwrapped UVs, that's about it. That's more than enough. You don't have to optimize this or anything because you're never going to put these into Substance 3D Stager, or sorry, Painter, and then create textures from them. If, for example, you develop these further, or you're gonna keep working on your grayboxing to take these objects to the next level, then yeah, you should probably go in by hand and design the UVs yourself, or at least optimize this process as much as possible so they look better and they look better situated in the UV space in a more conservative manner, but that's going to come in later. Okay, so let's forget about this. So let's import. Here we go. We have the entire set, as you can see. Okay, let's find a good angle, like similar to what we have in Maya. Okay. First things first, we have to get rid of the ground plane, or at least we have to raise these in height. Well, since these objects are intended to be used in space, they can be observable from 360 degrees around on a spherical fashion. So there is no ground as far as these things are concerned. So we can get rid of the ground if you go to Environment in your Scene tab, and then select Ground, and you can disable the ground plane. Now they're floating in midair. Perfect. Second thing, we have to specify materials. Now we applied the same material to all objects, and it is standard surface 1. If we open it up, it just uses a boring gray color, like, I don't know, 33%, maybe 25% gray, I don't know. It's really boring. I'm going to, breathe some life into it, make it a more tannish color, sort of a desaturated orange. A very light desaturated orangish red. Yeah, it looks better. It looks like clay. Those of you who used ZBrush will remember this kind of material usage. It looks better. It is more comfortable to the eye. Okay, if you want to specify, you can specify the roughness as well. That's going to change the highlights on these materials. I personally like it in the middle, because it is not too shiny to suggest a glossy surface, but it's not too rough so that we start losing all of these beautiful circular or spherical or cylindrical details. So it's somewhere in the middle. 0.5 is perfectly fine. You can further play around with the values over here, but I don't feel the need to, so I'm going to leave it as is. Second thing, let's go back, third thing, or rather, let's go back to environments. Now, we are not using background, or we can use background if we want to, but doesn't matter really, because you will have the option to change that later on in Photoshop. And if you go to lights, we are using this specific environment light right now, and this is a basic studio setup with directional lighting, soft and edge lighting, and that's perfectly fine. But if you want to further add some life into these things or change the quality of the light, you can do that. But keep in mind the purpose of this graphical representation is simply that. It's a graphical representation. It is not intended to be cinematic. It is not intended to be dramatic. So try to stay away from shadows, harsh shadows specifically, because the purpose here is to make people understand the general outlines, the general shapes, and the way these objects attach to each other. So your lighting conditions, your lighting scenario shouldn't hide all of those details. If anything, it should make them visible, make them understandable without sacrificing the three-dimensional quality, the shading quality of the object. So, for example, let's take a look at the 3-point soft overhead. We can simply drag this here, or not here apparently. Oh yeah, it worked. I'm sorry, my bad. This looks much better. It looks a bit flat, but we can still understand the general geometry of the objects, and you can always play around with the rotation, you know. Some areas are still shaded, some areas receive less light than others, so I can understand the separation of the three-dimensional qualities of the object. But at the same time, it is not dramatic. I can see everything rather clearly. Okay, so try other stuff from here as well, but our suggestion is you should stay away from anything, any light that incorporates a real-life light source. So for example, if you were to get this cave entry, there's going to be a lot of green tints because of all of the green leaves in the scene, or the canopus ground, for example, it will be orangish in nature. So a small apartment, it uses tungsten light, so the lights will be yellowish. So try to stay away from those and try to use studio setups. And maybe sometimes you can use over the clouds because it is just daylight, standard daylight with blue sky. It's not going to look bad, but yeah, just be careful about the lighting conditions. Then we have to set up a camera, and we can add a camera from here. Now, idea here is to get this, render this from as technical of a perspective as you can. And for that, we're going to consider this almost like an isometric perspective. And it is unfortunately impossible to get an isometric camera in Stager because that's not an option. The parallel projection simply doesn't exist for some reason in Stager. I know, Adobe, right? So, but you can fake that, you can cheat that, and the way you do that is practically increasing the focal length of your standard camera by a lot. Because the longer the focal length of a camera gets, the more zoomy, the more telephoto a lens becomes, closer to parallel projection the light rays become too. So, for example, instead of using 50 millimeters, which has some amount of observable perspective in it, as you can see, the object here appears larger than the object in the background. That's basic perspective, and I can exaggerate that by a lot. Right? This is distorted right now. It is incredibly, objects are impossibly large when they are close to the camera, and they are impossibly small when they are further away from it. But you can do the opposite. You can basically start squishing down all of this information by increasing the size, going over the slider even, and going as far as, for example, 1000 millimeters. Now take a look. Objects appear in an extremely similar size, and you can even do this, and you can see that, the object in the background is slightly smaller than the object in the foreground, but you can push it, and the more you push it, the more close they're going to appear. And at some point, you won't be able to understand that this thing isn't a parallel projection in the first place. This is good enough. And we are not trying to use real isometric, like the angles here not being 60 degrees or whatever. We don't care about that. Looking isometric enough is good enough, okay? And then we have to find a good angle. That's perfectly fine. Never mind the cross here. Never mind the weird artifacting with the background or weird artifacting that might appear on the models themselves. If things seem all right in, for example, Maya, if the object smoothing and, you know, the way these lines are harsh and these lines are smooth, if everything here is fine, they will be fine in Stager as well. Don't worry about it. Then we have to go to our camera settings once again, and we have to specify our resolution, and what that resolution was is 4735 pixels by 2636 pixels. Let's type that in. Was that the right resolution? Yeah, it was. Okay. Now, oops, we have the right resolution, okay? Then we can go to render, and let's do an extremely quick render to see what's going on over here. And the way you can do that is, before anything else, we have to set this up. So let's go to, oops, not this one. The appropriate folder right here, and let's name this Space Station Render 1. Okay, maybe underscore over here. That's good. And instead of PNG, we're going to use PSD, because PSD will give us a lot of options. Let's render this. So there we go, we have the render. That's good, it's finished and saved. Let's take a look. It's here, Space Station Render 1 camera. Okay, let's open it up. Now, since this is a PSD file, it's going to turn out like this, obviously. First things first, oh, this is way too close to the edge for my comfort. Maybe I should fix this later, okay? So this is a good place to start to see things, right? Maybe I shouldn't have done this. As you can see, it's too close to the edge. So maybe I should just either, you know, move this around just a touch to center it on the screen, like so, to fix that problem. Okay. There you go, much better. Okay. So here we can use this file now. Let's go back, open the new version, and here we are. So first things first, the idea behind saving this as a PSD file is that I can remove the background entirely or changing to whatever I want, including color or gradient or whatever, okay? So if you save this as a PSD file, most everything will be editable, which is good, which is something we want, okay? That's first things first. Then you also have the option to switch between the denoised version, okay, because we had the denoiser open to get rid of the noising, the artifacting at the end of a very short, very low sample rate render, okay? And you can also see the noisy version. As you can see, the noisy version is really, really noisy. But the good thing about this is that you could incorporate the two of them together to create some more life in these things. So for example, I can drop the opacity of the noise, and it will incorporate some amount of texture to these, okay? This is good looking, okay? So I can group them together and say this is the main render, right? And then the background color, for example, I don't care about this. I can simply use background image, and for example, I can paint it all white. So this is going to be white background, okay? All right. Now, the idea here is to create what we call an exploded perspective. If you take a look at exploded perspective examples, Exploded perspective is used in the industry, many industries, including industrial design, mechanical engineering, robotics engineering, architecture, interior architecture, even in our case, video game design. Exploded design is intended to tell the story of an object by separating it into its pieces in a very let's say schematic fashion, right? You separate the pieces of the object, lay them side to side, and the purpose here is to make them all visible, but by keeping their context intact. So how they connect to each other, how they work with each other, how they join together, that remains intact as much as possible through graphical application. So it is not just drawings. As you can see, this is what we call annotations. So you specify how objects attach to each other through line work, and you name them, you number them, you specify details, right? You say this is what this means, this is what this object is intended to do, and in that context you can even use icons, right? In order to not write stuff and crowd the canvas, you can even use icons. You can immediately understand that, hey, this is a toilet. Like, nobody who lives in a modern society will not understand that a man and a woman sign next to each other is not a toilet. Okay, everybody is going to understand that. And this is 85 cars, 20 bikes. Of course, it's a parking lot. We can understand that. And same thing here. And this is perhaps a booth of some sort, right? But at the same time, it is harder to understand what that icon means. You can understand the popcorn. Yeah, this is the cinema. This is the projection room. This is the foyer. Right? They had to write it because it's not understandable. Some of them they have wrote here, but there you go. You can use icons as well for telling the story. And if that is the purpose, if the purpose is not drama but to be informative about what this is, then start thinking about it in terms of graphical design and stop thinking about them from, let's say, a game perspective. Okay? So here, for example, these things are floating in midair, but I want to ground them somehow. I can simply go to my main render, double click on it to open up the layer style, and probably add here a drop shadow. Okay? Let's give it an angle, like so, and let's give it a distance. Okay. Like so. Let's make it softer. Hit OK. And simply by adding a drop shadow, which is not a real shadow in any way, simply by adding that, these objects started to pop out from the paper. Now that I can, clearly see their outlines, they almost feel 3D again, even though they are two-dimensional images, right? So there you go. Now, this is the vehicular example, and as you can see, it's right now flat. So before I continue on, I want to show you another thing. So let's reset this, okay? Well, what if I wanted to do this example? Because the difference between an architectural example such as this, intended for pure level design, let's assume that this is, for example, level designers and game designers to use for building levels. Like, this modular system will not be apparent to the players. The players will never be able to play around with all of these tools. You will. But on the other hand, Space Station is different. Space Station is for gameplay purposes. The player, as part of the gameplay, will take these objects, snap them together, perhaps, to create their own unique space stations, right? Maybe that's part of the gameplay. And because of that reason, for example, there are a couple of things different from the ground up. One thing is immediately apparent: these are all solid objects. They are closed. You can never see their back faces because their back faces simply are always on the back. They are not open, okay? So this is intended for final use. From whatever position you observe these, they are always intact objects. But that's not true for this version. As you can see, they are all about back faces. It is the duty of the level designer or the game designer to incorporate these things together and create levels while hiding the fact that outside of them is just empty space and they are just thin papers. They are not solid objects. They don't have any thicknesses because this is a highly optimized process. We don't need the outside of this. We don't need this wall built as a chunky piece, right? But we are not interested in that. So the way these things are built is different, essentially. And the way we can, for example, in this case, explain how they work should also be different. First things first, we are looking at it from the wrong side, right? But still, in order to understand the geometry of what's going on here, the fact that these are domes and whatever, we still have to look at it from this perspective. But in order to understand what goes on inside, we have to look at it from this perspective as well. We have to look at it from both sides. And separating them side by side might not work as intended, okay? Because yeah, similar to what I did in Space Station, I can just, line them up as a group of objects as opposed to objects that are joined together, but that's not going to tell the story because it is not as self-evident as what's going on in the Space Station example. In the Space Station example, after a few touches, you can easily explain that all of these halves and labs and tunnels and joints, they are supposed to go together. They are supposed to attach together. But in this example, it's a bit less evident, right? So it is better to show these objects joined together but painted in different colors, highlighted with different colors, so that the intended target of your presentation or anybody else who's supposed to understand this work gets the idea that these are all separate objects with separate purposes and a method of placement. So in order to do that, we have to export this, but instead of rendering it one time, or let's say in one orientation, we're going to do a render in both orientations, okay? Now, don't worry about, seeing the back faces, because here in Maya, you have to, use double-sided lighting, two-sided lighting to light up the surfaces like so. We usually don't prefer this because the direction of the face is extremely important, especially when it's broken and has to be fixed. So two-sided lighting is just for demonstration purposes only, but you shouldn't worry about it in Stager because Stager automatically renders everything as double-sided anyway. So you can export the selection once again. This is old Mosque. Yeah, I'm gonna replace it. Let's go to Stager, and this time import our old Mosque. Once again, I don't even have UVs on that model, but no worries. Okay, and here it is. And as you can see, since in Maya in the hypershade we have already separated all of our objects, all of our unique objects with different materials like so, those materials will be inherited by Stager as well. Okay, so this is perfect because now I can play around with it. Let's check the environment out, but before we do that, we have to come up with a solution to showcase this. Now, after I render it, I'm not going to play around with it, but I just wanted to show you what different methods exist for doing this stuff. So, for example, this time, let's forget about the focal length. Let's not try to push it towards isometric and use the perspective so we get a better result, because this is becoming spacious, or let's say spatial in quality, as opposed to an exploded perspective like we are trying to achieve here. So instead of trying to build an exploded perspective, let's try to visualize this building composition in order to tell the story of the asset design. So for that, I'm going to copy this and paste it and create an alternate version of it, but then I'm going to rotate it. Okay? Let's go to transform. Let's rotate it. Okay? Like so. And let's raise this as well to make sure that everything, you know, sticks out. Or you can, once again, instead of doing this, go to the environment and remove the ground as well. Okay? Like so. Then let's place this. Let's make sure our camera resolution is once again what it needs to be. Okay? Then let's try to find a good position for our camera and a good placement for this object as well, because maybe, you know, trying to represent it like this might be better. Okay, so let's try to do that. Maybe push it here, maybe push it here. Okay, let's make sure that these values are rather integers. Okay, this looks much better. Now I can see both sides of the same composition. One is a bit wonky and it looks like a weird way of telling the story, but immediately you can associate the two things together. First of all, it's really easy to do that because they are using the same materials, obviously, so you can associate the colors with each other. You can immediately tell that, oh, wait a second, this you know, water green, you know, aquatic green color is repeating here, so they are probably the same object. Same with this dirty yellow. So you get the idea. You can immediately associate these two things together. It's like looking at this thing from the bottom. If I were to set up my camera like so, I would get the same result. I mean, this is a rather shallow angle compared, but you can do that as well. You can do a shallow angle as well. Yeah, you don't need to do a, you know, a deep angle like so, or a steep angle, let's say, but instead utilize a shallow angle. So you can do stuff like this. Okay, maybe this might be much better because this is closer to the human eye, so it is easier to understand. So here, using this two-pronged setup, okay, we can explain the situation like so. And once again, if we go to environment, and this time I'm going to use over the clouds as opposed to, you know, come on, yeah, I'm going to use over the clouds and rotate it accordingly. But in the hopes of getting these harsh lights, I'm going to use an image light as well, and, you know, maybe increase its size a lot. Maybe check out its placement, you know, play around with its intensity so it's not too much. Okay, like so, and I'm good to go. Really, that's about it. Obviously you can change the colors. Maybe these colors are ugly, but this is how you would render a composition where all of the pieces are connected together. You don't always have to separate them, but I mean, separating them also is a graphical design choice. Like, what is the best way of representing this system? Is it when pieces are situated apart or put together? In the context of the space station, I think situating them apart better tells the story because, first of all, you understand the modularity of the structure. You understand that these are all snap-on pieces. But in the example of this architectural level design scenario, how things go together is far more important than what they look like when they're separated, because it's it's harder to imagine a person for putting them together in their minds and trying to figure out how this corner goes along with the arches and everything than it is doing that for the space station. Okay, so there you go. Now let's go back to our Photoshop and look at the other scenario. Look at the first scenario once again. In another thing about Stager is it provides you with additional layers. There are 3 layers. Okay, let's check them out one by one from the bottom up. So this is depth. Now depth is what we call Z depth. It is the relative distance from the camera, and since everything was super far away from the camera to begin with, because you remember how we were using a really long lens, so in order to get this all into the same frame, we had to push the camera over to that over to the horizon, even like very far away. That's why the depth shows everything black. Even if it didn't show everything black, it would show everything relatively in the same color, because we are looking at everything relatively from the same distance. Okay, comparatively, this everything is the same distance to cameras, simply because just how far away the camera is. Okay, so we're not going to use it, but if you want to, you can use it as a mask even. But there are better masks available. So for example, we have the object selection masks. Since every object here was a different object to begin with, every one of them is painted in a different color, and that is represented like this is random, but these colors can be quite useful as well. You can use these colors for separating objects, or you can use these colors for highlighting objects. But you can do that much more efficiently with the material selection masks, because since every material was the same, basically, or every object had the same material, they are all painted in the same color, similar to how they were all painted in the same color in depth. But using this mask is infinitely easier, or depth is easier, depending on what you're trying to achieve. So we're going to use the material selection mask. Let's make a copy of it with Ctrl+J. That duplicates the layer. Let's push it on top of the main render, and then combine main render with the material selection mask copy. And let's put it out there as a group. Okay, so we shut off the additional layers. We have the material selection mask, and this is, let's call this highlight, let's say lab. Okay, so right now it must not mean anything, but in my system, okay, these are the lab units. Okay, this is the lab unit. These are all lab units. As you can see in the asset list, there are different functions. Okay, if we check out the asset list once again, these are all lab units, different functions. And let's say that I want to separate my presentation according to different units, according to different functions, and I want to highlight them. So one way of doing that is just grabbing any additional layer that might work to your advantage. In this case, this one. Okay. And then I'm going to simply select everything that is not a lab unit, delete the area, okay? And you can leave it as deleted. It's not going to do anything different depending on the blending mode we're going to use. So let me get a pure black color, because that's what I need. Okay? That's perfect. Okay? So it has a little, yeah, that's good. Okay, we have that. Now check that out. If I use the screen mode, in the screen mode, black means fully transparent. So everything that is black will be completely removed from the scene, and the rest will blend in the, let's say, as a highlight almost, as a light source to the to the layers at the bottom. Okay, so we can use it like so. In that case, we can maybe first of all play around with the opacity. Okay, and if we are not happy with the color, remember that we can always convert this to a smart object, or maybe let's push the opacity back to its original first and then convert it to a smart object, because converting to a smart object while opacity is at a level different will primarily embed that opacity into the newly created smart object. So we want to keep it at opacity 100 if you want to later play around with it. And then, since this is a smart object, I can go to image adjustments and play around with hue saturation. And what hue saturation does, let me take it out from screen mode, is that it shifts the hue so that you can find a different color. And you can always play around with the saturation as well, like how saturated, how dark you want to go. These are all, but be careful with the lightness, because you will, if you increase the brightness, since there is black inside this layer, you will also start pushing black into gray range. You cannot push black darker than what black already is, but you can highlight, increase its brightness and make it gray. So be careful about that. But there you go. I can start playing around with the opacity, and perhaps, since this is a laboratory, I'm like associating the blue color with science. Okay, so let's go over to a color like this. I'm quite happy with this. Okay, let me delete the filter mask for smart filters, because that's not necessary. So let's go to screen mode and let's play around with the opacity. And suddenly you can see that these objects are now represented differently. And you can do the same thing. Once again, go to additional layers, grab the material selection, Control J to duplicate it, put it in here. Okay, now instead of the labs, let's select the hab units. Okay, oops, that used to work. Come on. Okay, Control Shift I to inverse the selection, and then we can simply paint everything black. There you go. Okay, this is highlight tab. Okay, and once again, let's turn this into a smart object. Okay, and put a hue saturation adjustment on it. Okay, let's make these green, perhaps greenish in color, like habitation, like reminds me of green color. Okay. Maybe give it a darker tint. Okay, let's delete the filter mask, I don't need it. Okay, so let's lower the opacity, but also switch it to screen mode. Right, there you go. Now, as you can see, we are not losing the shading information, we are not losing the overall grayness, the overall graphical visual quality of this work, but at the same time we are separating objects. Like, they don't look like material changes, but they look different enough to be understood as objects belonging to a different group in the same set. Okay, so you can do the same for all others. Other stuff you can do is, well, provide direct information about these things. For example, let me say these are the visuals. Okay, let's open up a new group and let's call this annotation. Annotation is basically any type of visual information that is purely used for providing direct information, like arrows, like icons, like symbols, like text. So that's annotation, and we're going to start annotating. And the way you can do that is basically get a pen tool, right? Set it up so it's going to be 1 pixel in thickness. That's fine, we can change it later. And let's say it's going to have a stroke, because instead of a fill we're going to draw basically lines. Okay, so I want to specify what this is. If I start drawing, and if you put hold the shift key, you can basically draw a straight line like this. So maybe make this 2 pixels. That's much better. Okay, let's assume that I'm happy with this. That's the shape. Okay, let's open up a text layer like so. Okay, let's get our Helvetica, and you can use a different font, but do be careful with this. Okay, and this is a laboratory, yeah, and maybe let's make this even bigger and make this full caps, something like so. There you go. You have started to provide direct information, basically. Okay? The other thing you can do is that you can start telling people how these things are supposed to attach to each other. For example, this is a docking ring, and as you can see, any piece that connects to any other piece carries the same docking ring. This is the basic hard point, the master hard point of this system. Any major piece in that system will use these rings in order to connect to all other stuff. Okay, it also has these smaller rings that can attach to different kinds of objects like solar panels. We can specify that further even. But you don't need to highlight every docking ring. We only need to say it once. We only showcase it once, just so the audience understands, oh, so that's how they attach together. So let's highlight it. For example, we can grab another highlight, but in this case, instead of using these material selection masks or anything, we can paint it ourselves. So this is docking, let's say highlight, docking ring, okay? And then we can simply go in and paint a black color. And let's paint it here so that the docking ring is easily separable from the rest. And since it is the same object, we can simply paint it here and carry it to wherever we like. Okay, so let's grab a brush. Let's take a look at the brush settings. I don't need that level of hardness. Maybe 90% is good enough. I'm using the black color, painting on this layer. It's, nice. Okay, good. And that's all I need, because then I can put it here, and then I can convert this to smart object and use a hue saturation adjustment. This time I'm going to colorize, because since this is pure black, no matter what I do here, it's not going to work, because it doesn't have a hue, like it doesn't have color information. So cranking its saturation up will not do anything. I need to colorize this. Okay, so maybe let's do something like this, like red. Slightly darken it down. Okay, something like so. Okay, and then delete the smart filter again. Okay, and then for example, let's try soft light now. Okay, and you can play around with the opacity even, but I think this is good enough. Okay, now we have highlighted one docking ring, and we can grab these two from the annotation, Control J to duplicate them, and simply put them over here. And maybe this is problematic because it is collapsing with other stuff, or it is colliding, sorry, with other stuff. So maybe we can get this shape and hit Control T to reverse its direction, or let's say scale it on a different direction, okay, like so. And you can even do, you know, the same for the other side. But instead of doing that, why are we not redrawing this? Just creating a new shape is much easier, you know. Maybe let's do simply this, okay? And get the laboratory unit, put it in here and say, this is universal docking ring, okay? There you go. You have just specified a major component that makes this, let's say, modular system work in the first place. And you can further specify how these things are supposed to attach to each other. Let's create another line. I'm going to begin from the center of this piece, okay, all the way from here, all the way towards the end, okay? Now let's check it goes through approximately from the middle of all objects. It does. And then what I'm going to do is simply change the line type to something like a dotted line, okay? And maybe increase the gap, okay? And maybe increase the pixel size so they appear a lot more robust or a lot thicker. That's perfectly fine. And then what I can practically do is add a layer mask onto this, and then by just painting black on the layer mask, I can erase whatever is not necessary, whatever is going to be obscured, leaving just this data over here. Okay, something like so, as if this line is going through everything. Oops. Or maybe let's go back and add this as well. Okay. Perfect. Okay. And there you go. Now the best thing about this is, since we have used a mask and not let's say rasterized this object and erased whatever, we can still go back to our line and grab the direct selection tool that will allow us to edit this once again, and from the stroke I can change the color, right? Check it out. Now it's a different color, okay? It's more bright. But at the same time, is it understandable? That remains to be seen. But you can always edit this out, since it's a vector object. You know, you can crank up its size to something like this, and it's much more visible now. Maybe let's play around with the color just a touch more, so it's even more visible. Okay. So let's make it darker, something like this. There you go. Now you're basically doing the exploded perspective. You're telling the audience, hey, take a look at these objects. They are in line and they can attach together. It's like they are separated, okay? Is it going to be the final version of the spaceship or the space station, or is it the intended way these things are supposed to go together? No, it is just showing that anything that carries this universal docking ring is meant to go together. That's the entire purpose, okay? One final thing, you can also provide symbols. So for example, take a look. While this is a docking ring, this is not. This is an observation window. Basically, it's not meant to connect to anything, but since geometrically they are similar, that might create confusion. In order to highlight that the fact that not everything is a docking ring, or not everything like in this shape is actually a docking ring. You might provide additional information about the purpose of this object, whatever that purpose might be. In that sense, we can simply go to Google image search and search for, I don't know, let's say eye icon, okay, something like this, okay, and maybe get this one. Oh, there you go. Let's open image in new tab. That's it, okay. And then, since this is not a docking ring connection, maybe we can get a no entry sign. No entry icon might be better. And we need a black and white version of it, okay. So probably this. This is a bit small, but I think it can work. Let's open image in new tab, make sure it works. Oh yeah, it does. So we can practically drag and drop, carry them over here. I don't know why it's not working, so let's try bringing it over as a separate object. Oh, it uses the alpha channel, that's why. So that's why it's not working. So let's grab the alpha channel practically. Okay. And then, you know, come over here and paste it, but it's going to bring in as an alpha channel. Oh, there you go. So here we go. Okay, let's invert this. Perfect. Okay. And then we can also import this one as well. Same problem. Come on. It's a BMP, that's why it's not working. Interesting. Let's save this image. Maybe not here. Let's copy this image instead. Put it in here. That's much better. Thank you. Okay. So now let's assume that this is even smaller and this is smaller as well. Okay. Perfect. And we can simply say, hey, take a look. See that part over there? And that's going to be 2 pixels and black and single line, if I remember correctly from our annotation standard that we have just set. Okay, and we can put these icons here, and this one is no connect, and this is observe. Okay, that's the purpose we are using these for, and we can, you know, choose a placement for them. Like this is no entry and also observe. Okay, that's good, but take a look at this part. Maybe that line should be in line with the axis over here, so maybe something like so. Okay, this might be much better instead of using that. Okay, there you go. And we can do the same for here, because remember that this is a cap piece. It caps any docking ring. So we can simply use the same no connect over here. And just draw a line like so. Grab this and say, hey, this is not a connection either. All right, that's it. And you can specify further details. This is how you build graphical information in Photoshop using a render of your modular system Greybox out of Stager. Okay? You can add a lot more to this, but always remember the purpose here is not dramatic effects. It's not for you know, the artistic quality of things. You are simply trying to design a system and make sure people understand how the system works. Okay, doesn't matter about the style of it, the narrative of it, the story of it. Okay, so make sure you create this informative graphics with that in mind, and when you're finished, you can render it out as a JPEG or whatever and call into your presentation template and just simply drop it into this box. And sometimes you will need to create more than one of these depending on the complexity of your design or the you know, the methods in which they are brought together, or maybe you will simply share an exploded perspective or a lineup of all of your pieces, but in a separate page you will gather them together and showcase how they are meant to go together. All right, so that's it. This was the end of the Greyboxing tutorials. I hope you enjoyed. I'll see you in the next one.